Section 1.4, homework number 1 and number 2. So here we're going to learn how to round a number. So for example, the first one is asking us to round this decimal to the nearest hundredth place. And the second one is to round it to the nearest hundred. And here I give you two examples here. So for example, for decimals, if I want to round it to the nearest tenth. And so first we need to answer that question. What is the answer if we round it to the nearest tenth? And secondly, we need to explain why we round the number the way we do and use a number line. How in the explanation, we must use a number line. So there are three questions we need to answer here. All right, so first of all, I'm going to try to see. So normally when we teach students, this is what we tell them to do. So we say, okay, first let's find the 10th place. So this is, which is right here. And then we're going to look at the smaller place value and then the tenths. So the one to the right. If this big number is, if this digit is bigger than 5, we run it up. But if it's less than 5, we're going to just keep it. So we get 6.2. So in this case, we know the answer. First of all, if we run it, the answer is going to be 6.2. Now, the important part is to explain why. So you cannot, that your explanation cannot be, okay, because I learned what I was told. If it's bigger than 5, if it's less than 5, we run it down, or we just ignore the rest of it. And that's not an explanation why we do it. Because the question we need as teachers, we need to make students understand why we run it up when you have a digit bigger than greater than or equal to 5, but we run it down when you have a digit less than 5. So why do you do that? So we don't, when you say, so you cannot use that as an answer, because that's just telling students to memorize how you run it, but without giving any explanation. Okay, so here is the explanation. What we do is, and when we do rounding, we always want to round it to the closest number. So for example, 6.248, we round it down to 6.2 and not up to 6.3. Why not? Because the explanation is because this number is closer to 6.2. So for example, just to give you a real life example, if you bought a TV for $1,999, and you're going to say you spend $2,000 because $1,999 is closer to 2,000. You're not going to say it's 1,000 because 1,999 is much further from 1,000 than from 2,000. So whenever we do rounding, we have to make sure the answer is closer to any to the other ones, other possible ones, to the number. So or the number is closer to the answer. So let's take a look how we use a number line to explain. So first of all, we know this number. So we want to pretty much, you have two options. Well, either you run it down to 6.2 or run it up to 6.3. So we know this number is between 6.2 and 6.3. And we know the one, so how do we know that? Next thing we want to do is to put the number given, 6.248, on the number line to see which the number is closer to which number. So if this is where 6.248 is, then it's closer to 6.2, further to 6.3. But if this number given is right here, then it's closer to 6.3 than to 6.2. So it depends on where that is, where the number is. Now usually we will find the middle point. So this one is the middle. Well, maybe it doesn't look very good, but this one is the middle right here, middle line, middle. And we know the one in the middle is exactly 6.25. So why do we always compare to 5? Because halfway through of any place is always point, always a 0.5 or 0.05 or 0.005. Because, you know, halfway, for example, from 0 to 1, halfway is 0.5. But if you have 0 to 0.1, halfway is going to be 0.05. So it's always half of um, the length of the interval. So that's why we always compare to the digit of 5. And now 6.24, because 4 is less than 5, which makes the point, which tells us the point has to be to the left. Smaller numbers to the left, right? So that tells us it's closer to 6.4 than to 6.3. So the explanation you're going to have to say cannot be because 4 is less than 5. That's why I run it down to 6.2. It's not, that's just asking, that's the step, that's the instruction for how to, but not why you do this. Okay, so the explanation should be, from the number line, we can tell that first we know this number is between 6.2 and 6.3. So the answer is either run up to 6.3 or run down to 6.2. But we found the middle point, which is 6.25. And when you plot the numbers, 6.248. So this dot that I drew here is 6.248. And because it's to the left of 6.225. So of course we are going to, so we in previous section section 1.3 we already learned how to compare numbers. So we know this is smaller than 6.25. So it's going to be to the left, and then that makes it closer to 6.2 than to 6.3, because the middle is equal distance to both of them. But if you're to the left, that means it's closer to 6.2. Okay, and so here, this sentence is very important. Why did you run it down to 6.2? Because 6.248 is closer to, sorry, here should be 6.2, not 2, 6.2, than to 6.3. So we round it down, rounded to the nearest tenth, and that is 6.2. So when you see the word nearest, it really has to be the nearest, closest, or you can say. Okay, so now let's look at the other one with a whole number. So we first of all, how do you round to the nearest hundred? We found the hundredths place, so that's the ones, that's the tenths. And next, that is the hundredth. I'm going to switch to my example. And so in my case, I have to round this number to the nearest tenth place, the nearest tens. We're gonna first found the tens place, so that's 1, that's the tens, and then we look the number to the right, whether this is bigger than 5 or less than 5 or equal to 5. So if it's exactly 5, we also run it up, and so that tells me I need to run this up from 9 to a 10, but we cannot put 10 in this place, so which means I'm going to have to put a 0, and then add another 0, and another 0, and then we keep adding the 1, so eventually we add 1, 2, 3, that gives us 4, and of course this is 5, we're going to just drop it and make it a 0. So that's going to be 40,000. And again, this is how we do it, but why did we do this way? So why, when the number is 5, in the ones place, we're going to have to run up. So we're going to explain from on the number line. So first of all, we know this number. So whether if we run down, we're going to get 39990. But in this case, actually, we have to run it up to get 40,000. So first of all, we know this number is between 39,990 and 40,000. And we need to find where the number is. And notice the number is actually exactly in the middle, 9, 9, and 5. And so if it's, this is just a convention, if it's exactly in the middle, we're going always to, I mean, it's literally equal distance to both numbers, right? So we are going to, we have to make an agreement. So everybody agrees that we're gonna, in this case, we're gonna run it up. So although it's 40,000, so this number of 39,995 is equal distance, not really closer to 40,000, but we're still gonna run it up. All right, so we're using the with 5 run up convention. So we got the answer 40,000. In your case, you will not run into this situation. So again, make sure your explanation says something about it's closer to this number. Don't give me answer. So the the incorrect answer is like when I ask you, for example, in the first example, why did we run this down to 6.2? You cannot just say because 4 is less than 5. Well, because students may have may feel confused, like why less than 5 you have to run it down. Well, in this case, why 5 you run it up. So instead of asking them to memorize it, say, hey, less than 5, you got to run it down. 5 or upper, you have to run it up. So literally, we're asking them to memorize it. But we actually can use a number line to show them why, to explain why. So that's because if it's less than 5, it's going to be closer to the left end. But if it's 5, or it's actually, if it's bigger than 5, it's going to be closer to the right end. Although at 5, it's equal distance, we pick the right end.